Hello guys, welcome to our class. For this particular class, we are going to be discussing Wheatstone Bridge. We've already discussed potentiometer. So for this class, we are looking at Wheatstone Bridge. Don't forget that these instruments are used to measure uh, accurately different variables in physics. Potentiometer for measurement of EMF, and you can also use it to measure resistance of cell. Then the Wheatstone bridge is actually used to measure accurately the resistance of a cell. Is that okay? So it is another instrument that is used in physics practical in your laboratory. So in case you want to carry out any practical on Wheatstone bridge, at least you should be able to understand the principles, the working, and then how to do simple calculations on the Wheatstone bridge experiment. So that okay? And if you see any calculations on it, you should be able to solve them. They are easy. It's just for you to understand the diagram and the working principle of the Wheatstone bridge. So guys, if you have your writing materials ready, this is number assigned to source online. And please, before we go to our class, if you have not subscribed, please subscribe to the channel. Click on the notification bell so that whenever we upload a video, YouTube will notify you. Please also encourage you, invite your friends to come and enjoy what you are enjoying. Give us a like, give us a thumbs up, give us a positive comment. And if you have any challenge, please reach out through the WhatsApp number that's showing on your screen. You can also click on the WhatsApp link that is down below this video. Alright, so thank you so much, and then we welcome you to this class. Please let us go straight to the class for today. We are looking at the Wheatstone Bridge. So if you are ready, let's go. Okay, so as I said, the Wheatstone Bridge is an instrument that is used, right, to measure accurately the resistance of a cell. Okay, so if you look at the drawing, you see that it has different resistors that are connected, and then you have your galvanometer, then this is the key, and then this is your cell. Okay, this is the key, and this is another key too, then the current that is flowing. And so this is basically the drawing for the Wheatstone bridge. Now if any of these resistances is unknown, you can from the formula for the Wheatstone bridge, you can use it to find it. And that is basically what we are going to discuss here. Alright, so for the Wheatstone bridge, a balance point is obtained when there is a non-deflection on the galvanometer. Okay, when there is a non-deflection on the galvanometer. So at balance point, that is when you have net deflection, the potential between B and D are the same. So B and D at balance point, they will be at the same potential. And once they are the same potential, it means that the potential difference between B and D is 0. The potential difference between B and D is equals to 0. Now if you look at this drawing properly, you will observe that the resistance R1 and R2, they are in series, and R3 and R4, they are in series, but R1 and R3, they are in parallel, and then R2 and R4, they are in parallel. That is one thing, it's one key thing that you need to take note of when you are working with the Wheatstone bridge, because sometimes you go and you might write this equation, and then you write it wrongly. That's okay. So please, you follow through so that you can be able to know how to arrange these resistances when you are solving for any of the unknown. So now what I've said is that the current through R1 is equals to current through R2. Why? Because they are in series. Similarly, the current through R3 is equals to current through R4, because R3 and R4, they are in series, but R1 and R3 are not in series, they are in parallel. And R2 and R4, they are not in series, they are in parallel. You need to take note of that. Okay, so if you understand that, and that is the statement that is written here, current through R1 is equal to current through R2, current through R3 is equal to current through R4. Now, having known that, another thing that you need to know is that the potential difference across arrow 1 is equal to the potential difference across arrow 3. Know that when resistance are connected in parallel, the PD across the resistances are the same. Okay, so the PD across arrow 1 is equal to PD across arrow 3. The PD across arrow 2 is equal to PD across arrow 4. Okay, so that is what I have written down here. So if we know that, then it means that PD across arrow 1 is current through arrow 1 multiplied by the resistance of arrow 1, which is this. That is I arrow 1 times I arrow 2. The same thing too, which is the current through arrow 2, the current I2 multiplied by arrow 3 will give you the PD across arrow 3. So, and that is what we have here. Then similarly to the current through arrow 2 multiplied by its resistance is the PD across arrow 2. The same thing goes for this. So by the time you arrange your equation, you find out that I1 will cancel out, I2 will cancel out. So this is what you have as your final equation. And this is basically the equation that you need to solve for any of the resistances that is unknown when you are working with the Wheatstone Bridge. Now, what I was trying to say is that if you look at this equation, if you don't understand this drawing very well, you will not be able to know how to arrange these resistances in order for you to get the accurate or the right answer or the right value for the resistance. So you need to know that when you have your Wheatstone Bridge diagram, always look at this this line. So when you look at this line, it is from this divide that you will know that okay, this resistor is parallel to this and this is parallel to this. This is in resistance to this. I mean, this is in series to this, and this one is in series to this. So once you know that, you will now know how to arrange. You will know how to arrange your resistances for any question that you want to solve. Okay, so here you see that arrow 1 all over arrow 2, arrow 3 all over arrow 4. Very easy. So from here you can calculate the unknown resistance for the Wheatstone Bridge. Okay, so please let us just solve a problem so that we'll see how we can apply this equation. All right, so this is a sample question and it's a NECO question. So it says that in the diagram below, the galvanometer indicates a null deflection. Calculate the value of R, which is unknown, and then the PD between P and Q. Okay, so here we already have our equation. So our equation is so here I can label this to be arrow 1. Okay, so this is my arrow 2 and this is my arrow 3, and this is my arrow 4. Okay, so fine. So that's my arrow 4. So now we can write our equation. We can put down our formula, and our arrow 1 all over arrow 2 is equals to arrow 3 all over arrow 4. Okay, right. So if you look at this, I was not giving arrow 1, arrow 2, arrow 3, arrow 4. That is, it was not indicated whether if this one is the arrow 1 or this one is arrow 1, this arrow 2 or arrow 3. It's not indicated. I'm only giving the values of the resistances. But I was able to know that this is arrow 1, this is arrow 2 because if I put this line here, okay, if I put this line here, I would know that okay, this resistance is parallel to this, and this resistance is parallel to this, and this is in series with this, and this one is in series with this. So this is what will guide me once I'm able to know this 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 diagonal line, I should be now able to know how to arrange my resistances as R1, R2, R3, and R4. Okay, so once you have done that, you can now put in your values. R1 is 4 ohm, and this is R2, which is 2 ohm. Is equals to R3, which is 3, and this is your unknown, R4. That's your unknown. So just make that the subject of your formula so that you have your answer readily. So as I said, calculations on this, actually they are very simple and easy. It's just for you to understand how to apply the formulas for you to solve. Okay, just for you to know how to apply the formulas for you to solve. So that is 6 over 4, and then when you work that out, you have 1.5 ohm as your value for the unknown resistance. Okay, so we said that at non-deflection, the potential difference between A and B, between P and Q, is equals to 0. Yeah, so the second option is that the PD between P and Q is equals to 0. That's all. Because at non-deflection, the potential difference between P and Q is equals to 0. Okay, so there's no potential difference between P and Q at non-deflection. So for this one, that one is equals to 0. So this number 2 is equals to 0. That's what we mentioned or we discussed before. Okay, so this is how to go about this type of question if you come across them. Alright, so I hope this is simple. So let's try another one. Alright, so this one says that in the diagram below, the galvanometer indicates a non-deflection. Calculate the potential difference between X and Y. Alright, so in the diagram below, the galvanometer indicates a non-deflection. Calculate the potential difference between X and Y. So for this particular question, it just takes you to understand that at non-deflection, the potential difference between X and Y is equals to 0. This is actually an objective question. So for this one, you are not going to solve anything. Yeah. So and that is just it. Okay. That is just it. The potential difference between S and Y is equals to 0, and that is it. Right? Because it is non-deflection. Okay. So I think that is all for this particular question. There's nothing to solve here. At non-deflection, potential difference equal to 0. Take note of that. Okay, guys. So these are questions for you to solve. Please go through them and solve them. There's no plenty stories about this. So this is what we have discussed already. Solve them. If you have any challenge, let us know. All right. So thank you so much. This is where we are stopping our class for this section, and this is where we are ending this session. We thank you for following us through, and we hope you understand this. All right. So before I leave, please subscribe to our channel, give us a thumbs up, give us a like, give us a positive comment, invite your friends, and so that they can come and enjoy what you are enjoying here on YouTube. This is Normal Science Source Online. We hope to see you in our next class. Please reach us through the WhatsApp number or through the WhatsApp link that is showing right down below this video. Okay, so thank you and wish you the best. See you in our next class. Thanks.